Okay, so let's try the next one. So whenever you're dividing a fraction, the first thing is, fraction by fraction, is you keep the first fraction, right? And you multiply it by the reciprocal, which means we flip this thing, the reciprocal of the second fraction, which means we have an 11 over a 3. Okay, now we can actually simplify these individually, right? 6 over 14, for instance, 6 over 14. We can see that we can divide both of those by 2, and that would give us a 3 over a 7. Now the 11 over 3, we can't simplify that. So I'm just simply going to rewrite this, but instead of having 6 over 14 here, I'm going to rewrite it as 3 over 7. I'm going to multiply that by 11 over 3. Oh, look, there's a 3 there and a 3 there. Cancel out, leaving me 11 over 7. And we got that one. Okay, so let's try the next one. So find the sum and write it in lowest terms. I kind of jumped in the deep end here, but basically there's something called like fractions, which basically means, and this I'm just making this up off the top of my head, so this is not related to that problem number 9 or any of the problems for that matter. And basically what this says is, let's say I have two fractions that I'm adding together and they have the same denominator. Those are called like fractions. Well, when you have like fractions, you simply add or subtract the numerator. So in here, this would be basically, the 2 plus 1 on top. We put it over 3. That gives me 3 over 3, which reduces to 1. But the main point I'm trying to get across here is we could add those together because they had the same denominator. They were like fractions. Now, as you can see, these two fractions do not have the same denominator. One has a 25 and the other one has a 5 denominator. So if we wish to add those together, they need to have the same denominator, just like this over here, the like fractions. So if they give you like fractions, add the numerators together. If they don't give you like fractions, meaning they don't have the same denominator, you make them have the same denominator. And the way you do that is you find the least common denominator, also called more generally the least common multiple. And what that basically means is basically what it says. So let's say we take multiples of 25, right? Oops, 75 and 100, okay? And let's say we take multiples of 5, 5, 10, 15, 15, 20, 25, 30, blah, 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 right? Well, it's basically what it says whenever you're looking for the LCD, or more generally called LCM, least common multiple. It's exactly what it says. What's the least multiple that's the same, right? LCM might be a little more intuitive. So again, the least multiple that's the same. Well, if we just take one multiple of 25, right, it's just 25. And the first one over here that's the same is the 25. So the least multiple of 25 and 5 is 25. That's the least multiple of both of those numbers that matches. The smallest of both of multiples that match. Okay, so what that means is I want to turn the 1/5 into 1 over 25 instead. So the question is, what do I have to multiply 5 by to turn it into 25? And the answer is a 5. Now, to keep an equivalent fraction so I don't break the fraction, I also have to multiply the numerator by 5, and I get 5 over 25. Now, you might ask, well, how did I know to multiply it by 5? Well, if you're good with multiplication, you could think of it in terms of what do I have to multiply 5 by to turn it into 25, or you could simply divide. Well, if I wanted to turn it into a 25, divide it by what it is, which is a 5 at this point, and that gives you the 5, right? So that's how you can also get it that way. So probably better to think of it in terms of multiplication, but you can also think in terms of division. Either way, you get that you need to multiply the 5 by 5 to get it to turn into a 25. So not too bad. Okay, now that's just the first step. So what we do is we're going to rewrite the original equation of 2 over 25, and now I'm going to add 5 over 25. That's 25, believe it or not. Okay, so now that gives me I'm going to write this extra step, but I'm doing this just to prove a point. Obviously, you don't have to write that. But since now that the denominators match, they're like fractions, in which case I can simply add the numerators together. So I say 2 plus 5 is 7. 2 plus 5 is 7, and that's over 25. Now, at this point, I would try to reduce this, but there's no common factor between a 7 and a 25 besides 1, right? I can divide 7 by 1, 25 by 1, because you can divide anything by 1. But that's all I can divide it by, right? I can divide 7 by 7, I can divide 25 by a whole lot more, but I can't divide it by 7. So besides 1, there's no common factor. That means this is in the lowest terms. All right, let's try another one. All right, so we're going to find the sum and write it in the lowest terms. Okay, so the problem here is, again, these are not like fractions. They do not have the same denominator. So first step, we make them have the same denominator. Well, how do I do that? Well, you can write out the multiples right? 121, 242. You can see this is really getting out of hand really quickly though, right? So we need a more advanced method to do this. Just like before I showed you how to simplify fractions, how to put them in lowest terms. I gave you a simpler method. I gave you a much more complicated method, but that works for uglier numbers, right? Well, I gave you a simple method on this one, but the problem with that is it breaks down pretty quickly. Whenever the numbers get larger, it actually becomes much more of kind of a pain. I mean, it does work. I'm being a little OCD, so I'm probably going to actually show you what it looks like when you get there, but you can see the point, right? So if you can brute force it still, but this is not a very clean method. So I'm going to show you a better method, which is basically you take the larger number and you divide it into the smaller number until it goes in some multiple. In this case, I got lucky in the first try. It works because I can divide 121 evenly by 11, and I got an 11. Now, if that didn't work, I would try 22 on the denominator, then I would try 33 in the denominator, and you would just keep trying larger and larger multiples of the smaller number until it went in evenly, and then that would be your least common multiple or least common denominator. I'll do more examples of those later on, so hopefully that makes sense. Okay, so what that means is I need this 11 right there to turn into 121. I can do that by multiplying it by 11, and I'm going to multiply the numerator by 11. Again, if you find that confusing, you can simply divide 121 by 11, and sure enough, it spits out 11, which is now what I have to multiply the numerator and the denominator by. Okay, so I have 96 over 121, and then I add in 11 times 1, which is an 11, and 11 times 11, which is 121. Now that I have like denominators, I can simply add the numerator together. So I'm going to write this extra step just to emphasize that. You don't have to write this extra step. Okay, we add. So 96 plus 11. So that gives me 97. Oops, sorry. So 107. Sorry about that. Okay, so 1 over 7 over 121. So another question would be, can you reduce this? And the answer to that is no. Because again, the least common denominator, I'm sorry, the greatest common factor of a 107 and 121 is a 1. And that's it. You don't have anything else common, so that's all you get in this case. So that's in lowest terms. Now be careful. Improper and proper fractions can both be correct answer, and mixed numbers can be correct answers depending upon what they're asking you for. Always read underneath the where you're entering the answer to make sure that you've given the answer in an acceptable format. So if they ask for an improper fraction and you give mixed numbers or vice versa, you might not get credit. Now just contact me, I'll probably give you credit, but just be aware that technically it's wrong if you don't answer the question in the format they ask you to. Okay, so write the sum and write in lowest terms. So this one's a little easier. These are like fractions and they both have the same denominator, so I can simply add the numerator together. Now notice when I'm adding the numerator, I'm not adding the denominator, don't do that. So when you're adding and subtracting, you add and subtract the numerators, you leave the denominator the same when it's like fraction, when they have the same denominator. Okay. So now what we have is a 2 over a 10. We can divide both of those by 2. And that gives me a 1 over a 5. So that wasn't too bad. Find the difference. Something to always remember is all whole numbers are understood to be over a 1. So really all they're saying is 2 over 1 minus 8 over 9. So your question is, what's the least common multiple or the least common denominator, because we're in the denominator in this case, the least common denominator of a 1 and a 9. Right? Well, it turns out that the least common multiple of a 1 and a 9 is 9, right? Because if you 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiples of 1 are just 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth, right? So it turns out that the least common multiple is a 9. So what we do is we go over here and we multiply that by 9. We also multiply the numerator by 9. Let me write that. That's very messy. So 2 times 9 over 1 times 9 minus 8 times 9. So 2 times 9 is an 18 over 9. And then we subtract 8 over 9. And now because they're like fractions, if they have the same denominator. Okay, so I'm going to add in this extra step. You don't have to write this down, but 18 minus 8 over 9. 18 minus 8 is 10. Right over here. Sorry about that. 10 over 9. Okay, so like I said previously, if they ask for it in an improper format, this is probably perfectly acceptable. If not, then you want to reduce that. So we would simply take 10 and we would divide that by 9. Goes in there 1. 1 times 9 is 9. 10 minus 9 is 1 with a remainder of 1. So we'd end up with 1 and 1 over what we were dividing it by the divisor of 9. So we end up with 1 and 1/9. Now, these are both acceptable answers. So one of these has been turned into a mixed number. The other one is an improper fraction. Depending upon the question, you just need to read where they're answering it, and it will tell you which format they prefer. If you do get it wrong, just contact me. I'll probably give you credit. But again, you just realize that in the future, especially when you get in college credit, they'll be very picky about stuff like that, and they may not give you credit. So just always be aware of the proper format of your answer. Okay, so we're going to write the fractions that represent the shaded and unshaded portion of the figure. Okay, so 1, 2, 3, 4, 5, 6. Okay, so we have 6 parts. Okay, so we have 6 parts. 6 parts. Okay, and one of them is shaded. One shaded. Okay, so let's see if we can answer these questions. The fraction that represents the shaded portion of the figure is, well, we'd have 1 out of all the parts, which is 6, right? Okay. Now the fraction that represents the unshaded parts, well, the unshaded parts are going to be, well, we have 5 unshaded, right? Unshaded. Wow, that's my handwriting. Okay, so 1, 2, 3, 4, 5. So in this case, we would have 5 parts that are unshaded out of a total of 6. So you always put your total. I guess I should really label this as total parts. Okay? So this is total parts, 6 total parts. 1 was shaded, and 5 were unshaded. 5 were unshaded. Okay? And that's it.